Hello, and welcome to a video about simplifying radical expressions, and we're going to do this in several ways. First, we're going to look at some beautiful, perfect radical expressions, and then we're going to look at not so perfect radical expressions, and we're going to write them in two different ways, in radical and rational form. Let's get to it. All right, so first, let's simplify some beautifully perfect radicals. And since we are going to have to use rational exponents, let's practice using them now so that when we get to the ones that aren't so perfect, it might be a little easier to solve them. So let's begin here. The square root of 49. So let's rewrite that as a rational expression. The base of my radical is 49. The exponent that 49 has is 1, and it's a square root. My answer is 7. Here we have a base of 8. 8 has an exponent of 1. The root is 3. Our answer is 2. Now, if you don't know 8 to the 1/3 power off the top of your head, I recommend you remember it, but you have a calculator. Why not use it? All right, the 4th root of 81. Yes, this is another perfect one. So we have the base of 81, has a power of 1, and the root is 4. 81 to the power of 1/4 is 3. Oh, check it out. We have a variable. This is why we really do need those rational exponents. Okay, so the base is x, the power is 12, and the root is 2, because it's a square root. 12 over 2 is 6. So it is still quite perfect. Let's continue. Ooh, a number and a variable. This just means we have two bases. Let's start with 16. 16 is the base. It has a power of 1, and it's a square root. X is the base. It has a power of 20, and it's a square root. The square root of 16 is 4. 20 over 2 is 10. Okay, the cube root of 8x to the 30th. 8 is the base. Exponent of 1, root 3. X is the base. Exponent of 30. The root is 3. 8 to the power of 1/3 is 2. 30 over 3 is 10. Another beautiful one, let's do it. The 4th root of 16, x to the 12th. Okay, so we have 16, power of 1, root 4. X, power of 12, root 4. 16 to the 1/4 is 2. X, whoops, that 3 didn't work. 12 over 4 gives us 3. Okay, so we had some perfect radicals here. Let's see what happens when they're not so perfect. First, we're going to leave them in radical form. Then we'll do rational form. Okay, so the 9th root of x to the 37th. Okay, so when we rewrite this as a rational exponent, we get x to the 37 over 9. Now, this is what that tells me. That tells me we're going to have to do 37 divided by 9. And that gives us 4 point something. Well, 9 times 4 is 36. So 37 minus 36 has a remainder of 1. So we are left with a perfect x to the 4th, because that's the whole number, but we're left with 1 left over x, which goes underneath the 9th root. let's try that again. Okay, so we have 5th root of x to the 49th. So as a rational expression, we're going to rewrite it as x to the 49th over 5. Okay, so 49 divided by 5 gives us 9 point something something something. 5 times 9 is 45. So 49 minus 45 is 4. That's a remainder. So we have a perfect x to the 9th and a 5th root with a remainder of 4 x's. Okay. The 10th root of x to the 37th. Let's do that again. I like rewriting it like this. I don't know why, even though I'm going to put it into radical form. I think it just makes it more visually obvious to me that we're dividing. Yeah, I think that's what it is. I really like that visual aspect. All right, so 37 divided by 10. Well, that one I know exactly is 3.7, but, oops. But, dot, 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 dot. So we have 37 minus 30, because that's what 10 times 3 is. That's 7. So we have a whole 3 x's that we can take out. But we are left with 7 x's under the 10th root. All right, let's do one more, the square root of x to the 25th, which really means x to the power of 25 over 2. 25 divided by 2 gives us 12.5. 12 times 2 is 24, so 25 minus 24 is 1. So we actually are left with a perfect x to the 12th and a square root of just 1x underneath the radical. Whoops. Okay, so what this means in these 4 problems is we are dividing. The whole number is given as a perfect exponent to the variable, and the remainder goes underneath the radical. When we're doing it in rational form, it's a little easier, I think, because we don't have to go back to a radical, or at least not the way that I do it. So let's try this out. Let's write an expression equivalent to these roots, and we're leaving it in rational exponent form. Holy cannoli, we have 3 bases. Let's do it. 16 has a power of 1, the root is 2. X has a power of 7, the root is 2. Y has a power of 11, the root is 2. The only thing we can simplify is here, the 16 to the power of 1/2. Otherwise, these fractions don't simplify. And that's it. Let's try the next one. 3 bases again. We have 64 with a power of 1, root 2. X to the power of 4, the root is 2. Y to the power of 15, the root is 2. 64 to the power of 1/2 is 8. 4 over 2 is 2, and 15 over 2 stays 15 over 2. Ooh, cubed roots. I'm excited as if I didn't write these. I did. I solved them. It's always fun to be surprised by your own self. All right, so we have 27 to the power of 1/3. X to the power of 9 over 3. Y to the 7 over 3. The cubed root of 27. So 27 to the 1/3 is 3. 9 over 3 is 3, and 7/3 does not simplify. And of course, lastly, but not leastly, is the 4th root. Ooh, so we have 256, power of 1 over root 4. That should be a 1. There we go. We have x to the 8th over 4, y to the 6th over 4. All right. The answer to 256 to the power of 1/4 is 4. 8 over 4 is 2. And I can actually just reduce the 6/4 to 3/2, but that's really as far as I can go there. Yeah. And that's it. So I think just a little faster than the radical form because we don't have to think about what it divides into as much and do some subtraction. We just leave it as a fraction. All right, and that's it. So the remaining delta math sections, if you're in my class and it's November of 2020, these are the delta math sections. Here they are, here they are. Otherwise, have a wonderful rest of your day, whatever day and time it is for you. Bye.